All right, guys. I know it's a little toasty in here, so I'm just gonna go ahead and get started with the lecture with this on. But if people have trouble hearing or are distracted, let me know, and I could go ahead and turn it off. But we'll just keep this on, keep ourselves nice and cool for lecture number 2 of objects. So glad to see you all here. Um, Again, please stop me if you guys have any questions. This objects are really important to really have a solid understanding of. So objects, arrays, functions, those are going to be like your bread and butter for not only for the interview, but also just succeeding in this program and just success as a whole. So I'll be giving like a little side, uh, like after I go over this lecture, I'll go over a little bit of comparing the two data structures. So there might be times where like an array might be the perfect tool for the job, and then there might be another time where a object might be your perfect tool for the job. Sometimes those two, you can do the same thing with both. They can both serve the same purpose, but it might be helpful to understand why you might want to use one over the other. Software engineering it's called software. Like you can kind of do things however you like. Like there's no like set way, but there's always going to be trade-offs of choosing one way or the other. And so it's always important to know those trade-offs and be aware of them. But in the end, you're just going to make a choice, and it's probably going to be wrong down the line. But if you at least know your reasoning, then you can at least defend your choice. So yeah, object methods. So these are functions that are housed within objects. Why might you want to do this is for organizational purposes. Like you might want to have, let's say you had like math functions, and you might want to keep those all into an object called math functions object that has all the math functions. You might have like geometry functions, or I don't know, trigonometry functions, and then you like keep those all in their own groups. So it's like useful for organization purposes. And you can think of an object that can be used as like a blueprint. So if you have an object that can be like your blueprint for other objects, then it helps to create your methods in one object, and then later on, like you can use the same methods, but also like overwrite some of them with your own methods without having to copy over everything. So yeah, those are some of the reasons why you might want to put methods inside of objects. But methods are just functions that are properties of objects. And we're gonna go over this, which is another popular like trivia, because for a lot of web developer interviews and just front end interviews in general, just because this is pretty unique to JavaScript, and so it's definitely very confusing, but at the same time it can be very powerful as well. So yeah, methods are actions you can perform on a value. So they're functions essentially, and we've been using them throughout the course. Slice is a method. So a string is just an object, and like under the hood, it's an object, and it has a property called index of. That's why you can just use dot notation to access that method that's on the string object. And this is just a function that accepts certain parameters. There's some methods that are built into JS itself, and so it's nice we can use them out of the box. So we've all seen examples like this before, and I'm going to go over how you can use. So like, for example, if you wanted to see if Brazil, because all this is really doing is, it's showing you what index it occurs in, but it's also showing you if a element in a list actually exists. And this is something that you commonly want to do, like, oh, like does this password, or like does this article of clothing exist in this list? Like it's a common functionality that you might want to add. And so I'll compare the difference between using an array for something like this and an object for something like this. But since we're on this, we might as well go into it right now. So under the hood, this index of, so that would, countries would be an object under the hood, and index of is a property of that object. That's a function. But just like a quick interesting note is that this function under the hood, it's like a for loop that loops over the entire array, and it needs to check. It goes, oh, are you Brazil? And then it goes here and it says, are you Brazil? And then it goes here and then it says, are you Brazil? And then finally it's like, yeah, it is Brazil. So then it returns this index of that array. So right now this array is really small, so this can happen really fast. Like it's gonna be less than like 1 second. It's gonna be very trivial calculation to run. But let's say this was like 1 billion items inside this array, then it might take a really long time. Like to figure out if an element exists in this array, it might take a really long time. So just as an example, for something like this, like if we had countries, let's see if you guys can zoom in. So if we had countries, and then I'm just gonna use like shortcuts, something. So if we had those countries and we wanted to see if, let's say or vowels, for example, let's say we wanted to count how many vowels are in a string, then you could do something like, if countries dot index of whatever character, so like if that character was like Z, does not equal to -1, which means it actually exists, then you want to log like this is not, or it is a vowel. And then here we could do something like it is not a vowel. So in this, we would expect it to be not a vowel, since the index of Z in this array is -1, because it doesn't exist in this array. So, but like using objects, this is like a comparison between arrays and objects. Using objects, this calculation can be a lot faster, like magnitudes of orders of magnitude faster, because again, under this method, this is like a fancy little method, but under it all is your classic for loop that just loops over this array and then sees and then checks each element. So that's going to take a long time for large elements. So how we could do this with objects is we could do something like let countries as objects and then have it be like, USA and then France. Or wait, why am I doing this example? A, E, I, O, and then U. So now we could do something like countries, and probably should have named it that, vowels. But if vowels, and then does anybody have a guess as to how I could check if a vowel exists in this array? Like the same way as index of. Yeah. Just accessing the property, right? Yeah, exactly. So if you just did vowels, Z, it's the same thing as the index of. But now these are like two ways to do the same exact thing, but this way is a lot more efficient because object lookups are instantaneous. Like there's no for loop. Like when you try to look this up, it doesn't go like, okay, let me check this. Let me check this, let me check this, let me check this. It doesn't do that like arrays. It just goes immediately to this address in this like So these are all like addresses, let's say, like memory addresses, but they're just like a symbol of a memory address. But it just goes exactly to this address, and for this object, it can't even go to it because it doesn't exist. But let's say it was like I, and it would just immediately go to I. So it doesn't. There's no looping involved. So this is like very fast, and I mean, for like an object of this size and an array of that size, it's not going to make a big difference. But as your array gets larger and larger and starts getting unwieldy to loop through the entire array and see if something exists, you should use an object in that kind of case for lookups. So then, so you might ask, like, why would you ever use arrays? Well, arrays preserve order, unlike objects. So let's say you wanted to have something like a browser history or something, or any type of history, then you probably want to use an array because arrays preserve the order of, like, when you push things into an array, you know what was pushed first, you know what was pushed last. Whereas in an object, like, there's no guarantee that if you loop through this object, it'll give you this in like this, in that order. It probably will, but there's no guarantee. So order is never guaranteed in an object. So if you wanted to store something where order matters, then you probably choose an array over an object. If you want to do lookups, like a lookup in the dictionary, or lookup if some element exists in that list, you probably want to use an object. And if you want to, I just want to compare the two data structures because they can be used for similar things, but there's some, you should use the strengths of each data structure. So yeah, does anybody have any questions about that? Like why this is faster than the other lookup? Okay, back to the lecture. Yeah, that's the same thing though. That's a good question. So, and you use index of in that, it's the same thing. It'll go through each character in the string and check, are you this character? Are you this character? So it's still not the greatest. It's similar to an array in terms of like what's actually happening is that it'll go through each character and then it'll try to look it up.
You can only do that if you're saying index of
Yeah.
whatever you're saying up to is a string, not an array, correct? Like it can't find an individual character in a set of words in an array, not an array, a object. So like there's an object with a bunch of key value pairs.
Uh-huh.
You can't find one individual character in there with this index of, right? You have to be searching a string.
Yeah, I think
Correct?
index of works for arrays and for strings, but not for, I don't think objects have that. Yeah, so it would be strings and arrays. No, it would be the same result. You could do the same thing here, like asking if z is in this object is the same end result as asking if index of z in a string of AEIOU or an array of AEIOU is not equal to -1. It's the same thing. It's not gonna like fail tests or anything, but it's just like this way is more efficient in terms of time. Like it'll be faster. The lookup will be faster because you're not looping, you're not going to each element or each character in the string, and you're not asking it, are you what I'm looking for? And then you go to the next one, you say, are you what I'm looking for? And you go to the next one, and you say, are you what I'm looking for? No, like this one, you just go straight to the memory address. It's like an address, and you just go straight to the house, and you ask, are you it? And then if it's not, then you're done. Or if it is, then you're done. You're not like looping. It's like, yeah, I think, so this kind of goes into like big O and like runtime and stuff, but I just wanted to give a quick little intro to that, but there'll be more to come on that later on. But I just want to like show why you might use one data structure over the other, because there's always like multiple tools to carry out the same task, but one tool might be better for certain things and another for other things. Great questions though. Are there any others? All right, so let's keep learning about methods and objects. So yeah, I mean, this is the index of method, and it returns 2 because that's the index at where Brazil occurs. So we can create our methods too. So we probably are very familiar with having an object that has strings as its values, but we can also, objects can hold objects, they can hold arrays, they can hold functions, they can hold numbers, they can hold any data structure as its property. So here we have a function that's an object that has a property that is a function, and we don't need to give it a name because this is the name. By giving it a property name, essentially it allows you not to define the name of this function because its name will be this property. So that's the like notation that you would use. And again, why you might do this is, organization, clean code, like keep all your things that pertain to, the fall season, like all the clothes for your fall season in like one object, and all your clothes for the winter. It's just like containering. It's like putting things in a container, organizing your code into blocks that are that make sense. And also for copying, like I said before, like if this is a blueprint, and I mean you could run this, you could have define all your functions outside of this. That could be fine. But if you have this object as a blueprint, and you want to make like instead of Grace Hopper, like a slight variation of that, like just full stack immersive or remote. There's the different courses, but like all of these are going to be similar except like a couple things. Then you use this as like the template, and then you like overwrite certain things that you for each, as opposed to just like creating new ones and just copying all this stuff manually. I'll give an example of that later on though, because that might have been confusing. But yeah, you just call it using dot notation and the function invocation. Stop me if you guys, yeah. Yeah, it's a key. I mean, yeah, it's a method, but it's also a key because all of these are keys and all of these are values. So it's a method and a key. It's still a key here. The value just happens to be a function instead of a string, but it's still a key. It's also a method. Yeah, it's a key that's a method.
Yeah, it's not intuitive to access Grace Hopper with my method being a method right there. I'm just saying my method is a key.
Yeah. It is a little confusing because if you didn't know what this looked like, then how would you know that this is a function? Like, how would you even know to like invoke it? Well, you probably have to go to the definition of this object and see what data type it is. Because like if this was in a different file, and then you're importing this object, then you don't know what this object looks like. So you might not know that it's a function you can call like this. But usually like VS Code and Sublime, they have like shortcuts. So like if you right-click this object, it'll say go to definition. You just go to the definition, it'll open up the file that it's actually defined in. You can see all the keys, and then you would be able to tell that it's a function.
So when the value of the key is a function, does that make the key a method?
Yeah. That's exactly.
We have an array of functions. So like
Yeah. Yeah. I think so. I don't see why you couldn't. Probably not. Um, I've never seen that in the wild. If you wanted to confuse the hell out of someone, then maybe. Yeah.
If you wanted to do index of my method, would you have to add parentheses inside there?
Index of my method.
Would you have to add my methods parentheses inside the?
You couldn't do an index of on this though, because it's an object. Index of is only for strings and for arrays.
If you get the in function, the in, like.
Oh, in.
Yeah.
Yeah.
In.
That would work.
Okay, so then you have to.
You could just. I think.
Last in my method.
Yeah.
Or my method parentheses in the function name.
I think so. Let me.
Either way, it's not a good
No, I think that's a good question. You mean like if you had like my method. I'm not 100% sure actually. Let me see if my method. Wait. Let me see how in works actually. I usually just do something like vowels. And I try to access, or I try to do something like this usually. And then this will be truthy if it exists, and it'll be falsy if it doesn't exist. So this should be truthy. I'm not sure. Yeah. So I usually do something like this to check if it's in, but I think what you're talking about, like, in vowels. Yeah, the same thing.
You don't need that.
Let me just make sure it's actually okay. So yeah, it's the same thing. You don't need to do the function invocation or anything. You just treat it like it's a regular property. Just because it's a function, there's nothing real special about it, other than the fact that you can call it with a function invocation. There's nothing else special about it. So all the rules still apply, I believe. Any other questions? Okay. So yeah, we call our methods the same way we call built-in methods. So now we realize that like under the hood, and don't ask me how, but like all strings, all arrays, all strings are objects in JavaScript. Not really sure, but that's the only way you could call like index of on a string, you know? Like otherwise, like you couldn't do that. So I don't know how they do it, how they work that, but it's an object. So yeah, methods in an object, they generally perform actions that's relevant to the object itself. So like what that means is like as a convention, like if you define a function within an object, you're probably going to use some of the stuff that object contains. Otherwise, it doesn't really need to be there. But like for example, this one's not doing anything. It's not using any of these properties, but usually in the wild, like you'll see objects that have methods and then they'll kind of use the properties in that object. Yeah, like, this is just an example of a parameter being passed. Same thing. Just a function takes a parameter. You could create a function with many parameters, with no parameters. So it'll return 112 for age. So now this is what we mean by, let's see. Yeah, so this is just saying, like, if Grace Hopper object, whatever this abstraction is, if it had a greet function and it said, hi to whoever it's conversing with, but we hard coded this, that's pretty redundant to type out Grace's rank and last name twice in the same object. So like in code, you always want to like do not repeat, like keep code dry. That's like a term that's used pretty frequently, like don't repeat stuff. And this is kind of repetition because we have all of this data within this object. So why are we hard coding it again? We could use what's inside this object. And so, it'll say I am Rear Admiral Hopper, but it could just say like I am Grace Hopper dot rank plus dot last, Grace Hopper dot last. In this function, you have access to all of these properties. So it might be weird because it's like, oh, like within this function, I'm gonna access like Grace Hopper, but you can access Grace Hopper, and then do dot notation or bracket notation to access any of these properties within this function. So here's the better way to do it, where it's not repetitive. Grace Hopper dot rank and Grace Hopper dot last. You always want to avoid hard coding stuff in code because it's not very flexible. And let's say let's say in this case, let's go back to the previous example and like figure out like why you really wouldn't want to do this. Because like, let's say, okay, so you have a giant code base and like you have a bunch of different phrases in this object. So you have greet, you have say goodbye, you have say hello, you have apologize, you have thank, you have all these different functions, all these methods, and you're hard coding everything here. Let's say that now you want to, now your rank changed. Because code is all about change. Like everything's gonna change and people are gonna want different things. People are gonna wanna change how it looks, change what the text is, change how it functions. They're always gonna wanna change things. So if you hard code stuff, that's more work, that's creating more work for yourself. And yeah, let's say her rank changes to like colonel or something. Then if you use those variables in all those functions, you just change this one place and it just permeates throughout. And that's like a beautiful thing. Whereas if you hard coded stuff, it'll work, but then right when somebody asks for a change, you gotta like go in and go to all the different places that you used it and like erase it and then like put your new thing in, as opposed to changing it all in one place. So that's a reason why you might want to always use variables, always stay away from hard coding values. So this way, all you have to do if you want to change the rank is change this, and everything else that uses that variable is going to be changed together. So it creates a lot less work because most of the time you're going to be working on a code base that exists already, and all you're going to be doing really is making changes to it. Or that's like a bulk of what people do. Any questions about this? So yeah, when we greet Gabe, it'll say, hi, Gabe, and my rank is Admiral Hopper. So yeah, methods, they frequently reference other properties in the same object. Okay. So now this is one of the most confusing things that trips a lot of people up is the word this. And we're gonna start off like there's a lot more to this than this. but we'll start off here and we'll just we'll take it slow with this because honestly, like, I've been learning JavaScript for 2 years and like I still get confused sometimes by this. So we'll take it slow. But this is the same thing as what we did before, because in this object, when we have a function and we refer to this, this is the object itself. So Grace Hopper, it's the same thing as saying Grace Hopper.rank, Grace Hopper.last, but this is a special word in JavaScript. It's a key word in JavaScript that, among many other things, in this particular context, it'll refer to this object. And like we might ask, like, why would we do this, right? Why would we ever confuse ourselves and use this instead of just using Grace Hopper? Like, let's be clear. Let's be clear. This is Grace Hopper, so let me use Grace Hopper, right? But there's a couple reasons why you might want to use this. And we can go into that right now. Where's my mouse? I've lost my mouse. It's weird. Okay, let me try to. Okay, so why you might want to use this is, for example, so you had what's like a, okay, so let's say you had a human, and then he had a speak method, and it was just like console log. So he had a name property. And okay, so you had a name property. It's John, and then this is gonna console log. Move this out. Hi, my name is human.name. So that's nice and simple. Human is that object. And we're not using this. So why even use this? Well, this is a great example because now we have human.speak. Hi, my name is John. But what if we wanted to use human as like a blueprint for a police officer? And so let's say we had police officer equals, and like you guys are gonna learn this later on, but object.assign is basically like slice kind of. It like copies. It makes a copy of the object. So let's say we had a copy of the object. So this is the new object that's gonna get made. And then my blueprint is going to be human. And then my new, like, I'm going to overwrite his speak feat, like, in this example, okay, so I'll just overwrite his name. And it's going to be cop guy. Right? And then now I do human speak. Hi, my name is John, police officer.speak. What do you think this is going to log, like the police officer.speak? Any guesses? I hope it does. Yeah. So, like, we tried to, because I don't want to copy this function again, because the cop is going to have the same, speak function, so I don't want to like duplicate it. So I just want to make a copy, we'll learn this later, we'll get to it, but I just wanted to give you guys an example of why we learn stuff. So you have this object, and you have this human, you have this name, cop guy, but this is human.name, not this new not like police. It needs to be police officer.name. So it's like you're kind of hard, even though you're not hard coding, you're hard coding a little bit because you're hard coding this object. It can only ever refer to this object, not new objects that are created. So if you use this instead, then are there any guesses as to what this second one will log? Yeah, or it'll be cop guy, because this allows you to be dynamic. It's saying like whatever object that is created, regardless of, it's not bound to be like human. It's flexible to whatever object that. So now in this context, this is human, but in this object's context, this is the object that we just created with the name cop guy. Now this might be a little confusing, but that's okay because. Wait, do you have a question?
I guess I was just trying to understand. So does it, this refers to the closest in scope object that the method is being called within?
Yeah.
Refer to that object that's closest in scope?
Yeah. See, in this case, it's a little different than scope because human is, in this police officer object, it's not, human isn't really, like, it just, the properties inside of human and the properties inside of cop guy are just combined into like a brand new object. So, yeah, let me log what police officer looks like actually. Oh yeah. The thing that you were talking about with scope, yeah, that makes sense because here in this new object, the speak is human dot, before it was human dot name. So this human is referring to like this object. So yeah, this would be the closest one. But let me just log what these objects look like. So yeah, that's what these objects look like. This human, it has a name of John, and they all have the same speak function. The speak function is the exact same because the only thing that we changed is this name property. We kept the human object and all of its other properties, of which one of them was speak. And so the fact that we're using this refers to the object that contains the function. So in this case, in this version of speak, inside speak it says this.name. That's going to refer to this object, police object. In this human object, this.name is going to refer to human.name. Whatever object is containing that function, that's what this refers to. But if we hard coded this to be human, then we goofed up because now, even though police.name is cop guy, inside the function, it's still human.name. So it's gonna refer to this object's name. And so that's why you don't have that flexibility anymore of like using stuff as blueprints and things like that. You're just hard coding yourself. You're coding yourself into a hole where this can only ever be human. And like if you wanted to like rename this too, now you're screwed because, well, I mean that's not that bad, but if you had like a bunch of other functions in here that all referenced human, I mean you could do Command D, but like if you wanted to rename this like Homo sapien or something, now you got to go in and change all these guys. Whereas if you just use this, like, it just works out of the box for you. So this is a powerful dynamic variable that allows you to not repeat stuff, not duplicate code, and keep things flexible. Keep things real flexible, because this is always going to refer to the object that is containing the method itself. Are there any questions about this? We'll go back to the lecture now. I think we're almost done with the lecture. It's not a very long one. But yeah, this references the object in the method, or that the method contains, or that the object that contains the method. So does anybody have any guess as to what this would log when we do gracehopper.greet? Kate? Yeah, hi Kate. I am Rear Admiral Grace Hopper. Yeah. We're just returning this in this case. And so basically this object is this entire object. So any guesses as to what this would log? Return object.first. Yep, it would just be Grace because it's exactly the same object. Yep, just another reference to the Grace Hopper object. Yeah. All right, so we'll use more of this. So just shout it out. It's okay if you get it wrong. Calc.sum. What would this output? Yep. Be 50. And then what about if I did calc, if I reassigned that property and then called the function calc.difference? Huh? I heard the right answer. So yeah, it's num1 is 20. Yep. 15.5. So yeah, you can just think of this as calc, as the calc object. But this is another fancy keyword that helps the language stay dynamic and allows you to do a lot of copying of objects without you having to go in and change all the hard-coded values. There's a lot more to this. There's actually a lot more, but for now, this is a good introduction. So JavaScript is an object-oriented language, but it's also a functional language. So there's like two different styles or paradigms of code, and one is called functional programming, where like literally everything is a function, and you wrap functions within functions within functions. Like you like constantly like use like functions that don't have like some sort of outer state to mutate or change. It's just one function return value gets passed to another function return value, which gets passed to another function return value. Um, Whereas in object-oriented languages, you might have like an object that represents like your state, and then you still have functions, but they like change that state, and then they, um, basically just utilize objects very heavily. But JavaScript is cool because you can learn two different styles by just knowing one language. So you can use it to be functional, you can use it to be object-oriented. And yeah, you learn a lot of just fundamental computer science concepts through JavaScript. Obviously, JavaScript is not like Java in the traditional sense, like class-based stuff. JavaScript is more like it kind of tries to copy that, but it's not at the core. It doesn't function the same, but a lot of the general concepts are still similar. And yeah, we're skimming the surface, but it'll help at this point to really practice playing with objects and just accessing properties of objects, accessing nested properties of objects, because those are things that are just like very commonly done in everyday programming. Yeah. Today's lecture is pretty much over at this point. If there's any questions, feel free to ask, but I'm gonna now go through pairing you guys up, and we'll get started with the exercises for the day. Feel free to take a little breather.